Let's move on to another example on homogeneity. So here's an equation of motion which is S is equals to ut plus half at squared. Now S is the displacement, U is the initial velocity, T is the time, half is a constant. We are going to be ignoring that all the way. A is the acceleration and T is the time squared, right? So unit for displacement is meters, unit for initial velocity is meters per second, unit for time is second, and plus half ignored because it's a constant, so no unit. Acceleration is meter per second squared, time squared per unit second squared, right? So simplifying all that, we'll see that s minus 1 and s gets cancelled. So we are left with meter only. S minus 2 and s2 also gets cancelled. Once again left with meter only. So I can see that each and every term in the equation is the same. That is, it has the same unit, that is meters. So this equation is homogeneous. Why? Because homo means same. So every term in the equation is the same. Trying another example out there, which is v squared is equals to u squared plus 2as, where v is the final velocity, u is the initial velocity squared, 2 is the constant. Once again, that is going to be ignored because we do not deal with constants when working out base units. A is the acceleration and s is once again the displacement. So unit for velocity is what? Meter per second. But since velocity is squared, so this whole unit is going to be squared. This would come up meter per second bracket whole square is equals to what? Again, meter per second bracket close and square on the bracket, because it's again velocity squared, so its unit will all be squared. Then it's 2as, where a is meter per second square, s is meters, so we end up with this meter square per second square, meter square per second square. And lastly, m and m gets meter squared, right? This m and m would convert into meter squared. So once again, this is m2s minus 2. Once again, this equation has been proved to be homogeneous. Why? Because each and every term in the equation is the same. Moving a step ahead and trying out one more example. This question says that you have to use base units to show that the following equation given below is homogeneous. And what is the equation? Equation is work done is equals to gain in kinetic energy plus gain in potential energy. I need to prove this to be homogeneous. So what is work done? I need to work out the formulas. First thing first, force into distance is work done, kinetic energy is half mv squared, and potential energy is mgh. Once again, keeping one thing in mind, that I'll not be considering the constants. I'll be ignoring this while working out base units. So force into distance is work done, and the unit for work done has been proved to be kgm2s minus 2. We have already worked out that in the previous video. Then it's kg m2s minus 2 for kinetic energy as well. We have worked that out as well. Then for the potential energy, it's once again kg m2s minus 2, right? So potential energy, kinetic energy, you can say, you can use the same unit for them as the work done. Hence, this equation is homogeneous again, because each and every term of the equation has the same base units.